morning, dear students. I am Lalit Kumar P Bhaiya, Associate Professor, Electronics and Telecommunication Engineering, Bharati College of Engineering and Technology, Durg. Dear friends and my dear lovely students, today we will discuss about the feedback amplifier, and this is the unit number 5 of your analog electronics subject. Till now we have gone through the various parts of this analog electronics, like the low frequency H parameter model, multi-stage amplifier, high frequency H parameter model, etc. Similarly, we have also seen the feedback amplifier. But the basic concepts now we will see here. The first question is, what is this feedback amplifier? What is feedback? And then what is feedback amplifier? Now you can see here, if I am having this block with a gain A and I am applying here the input V in and the output is V0. What is this? This is a simple open loop amplifier, and having the gain V0 by V in is equal to A. This is called as open loop gain. Open loop gain of the amplifier, output upon input without any feedback. And feedback amplifier is just to take the output sample, apply to the feedback circuit having a feedback factor beta, and then apply this output voltage of the feedback, that is Vf, to the input. Now this becomes a feedback amplifier. Here A is the open loop gain, where this beta factor is the feedback factor of the feedback circuit. This block indicates the feedback circuit. I can write feedback is shortly abbreviated as F/B. So this is feedback circuit and this is the amplifier. So this closed loop circuit with this amplifier is called as a feedback amplifier. Now this feedback amplifier having now in this case, before this applying the feedback factor, the open loop gain is V0 upon, I have written here open loop gain is V0 upon V in, that is equal to A. But now this criteria changes, and whatever is the difference available here, this V0 by Vd is the A here. So I can write open loop gain is given by V0 upon Vd is equal to A. And now we have to calculate the closed loop gain, that is gain with feedback. So this gain with feedback V0 upon V in is written as AF. This can be written as the gain with feedback. This is open loop gain. This gain we have to calculate, overall gain. In general, I can say the feedback amplifier is one where the sample of the output is fed back to the input through a feedback circuit, and this feedback circuit having a certain feedback factor, that is beta, which is generally less than unity, and this is applied here. Now this feedback circuit continues till you get the proper output. So here the difference between the input and this feedback circuit is the Vd is applied to the amplifier. In automatic circuits, in generally those circuits which are automatic with the application of the feedback, this amplifier will continue automatically till the Vd becomes equal to 0. This is called as the error voltage. This error voltage 0 becomes, then output will be stabilized, output will be set, and this output will work for the another instruments or devices or industry connected to this output. So this is the main feedback circuit. Now this feedback circuit having two types of feedback. One is called as with a negative feedback and another is called as with a positive feedback. There are two types of feedbacks available. What is negative feedback? If this V in is positive, then this feedback voltage is negative. This is called as a negative feedback. And if both are positive, then this is called as a positive feedback. Or both are negative, this is also called as positive feedback. If one of them negative and another is positive, this is called as negative feedback. So this is two types of feedbacks are available, either a negative feedback or a positive feedback, right? Have you got it, dear students? Now, where is the application of this negative feedback and positive feedback? This is a simply phenomenon of feedback. Now, this negative feedback is generally used in amplifiers. All the amplifiers mostly are used with the negative feedback, while this positive feedback are used in oscillators. In oscillators, we use the positive feedback, while negative feedback uses in the amplifier. So these are the very important one. Now what we will go, we will see what are the effects of the negative feedback and what are the effects of the positive feedback. Let us see. In this particular video, I am going for the feedback amplifier. Here amplifier is written means we will use the negative feedback. So what is the effect of the negative feedback and how this negative feedback can be connected, or how this negative feedback makes the different types of the amplifier, that we will see here. This is open loop gain here and this is the closed loop gain. Now I am going to tell you here, this negative feedback we apply here, then this negative feedback have the four types of topologies used in the amplifier. This is called as feedback topology. This is called as a feedback topology. Feedback topology. Four types of topologies are there. This is basically a four types which is used with negative feedback. With negative feedback. Now we will deal only with the negative feedback, not the positive feedback. So for negative feedback means we use the amplifier here. This total is called as negative feedback amplifier. And this negative feedback amplifier is dependent on the connection. And these connections are the four types. This is called as topologies. How this amplifier is connected with the feedback circuit and how the input and outputs are connected. Now I can remove this diagram and I will tell you the topology of this feedback amplifier. This is called as topology. Four types of topologies are there. Number one is called as voltage series feedback. This is one topology, voltage series feedback. Second one is current series feedback. Current series feedback. And third one is the voltage shunt feedback. Voltage shunt feedback. And the last one is the current shunt feedback. Current shunt feedback. So these are the four types of topology. Voltage series feedback, current series feedback, voltage shunt feedback and current shunt feedback. Now how this topology is formed, how this connection is formed. So there are two parts. First part is this one, either voltage or current, and second part is this one, either series or shunt. So depending upon these two, we can use the topology. This part is nothing but the sample taken, sample or you can say output given to feedback and sample taken, output given to feedback and sample taken. This part is related, that means this part is related with output. So directly I can say this is related with the output, whether output is voltage or whether output is current. So if output is voltage, voltage will be sampled. If output is current, the current will be sampled. And this is the input related, whether the input and feedback is in series or is in shunt. So this is related with input, related with input. So dear friends, remember to form the topologies of the feedback amplifier. The output sampling of the output, either it is a voltage or current sampling, and the connection at the input, either it is a series connection or it is a parallel connection, that is shunt. Series connection or parallel connection means it is the series feedback voltage or feedback current, whatever may be, is in series with the input, and parallel, that is shunt, means parallel at the input. So depending upon these two quantities, either at the output side or at the input side, this topology is formed, called as a voltage series feedback. Output is voltage and input is a series combination. Here current series means output is a current, that is output sampling is the current, and input is in a series. Series means input and feedback is in series, feedback quantity is in series. Output shunt, voltage shunt, output is the voltage sample and input is a shunt mixing, and output is a current sampling and input is a shunt mixing. So these four topologies are available in the feedback network. Now we will go the one, that is voltage series feedback, and in the next video we will go for the another this current voltage, these three types of feedback. So dear students, you have understand these things. First of all, I will tell you the voltage series feedback. Of course, all these topologies are with a negative feedback. Every topology, every amplifier is prepared with the negative feedback, and hence we will not refer again and again here the negative feedback. It is the chapter, or it is the amplifier related with the negative feedback. So here we will go through the voltage series feedback. Let us say this is the block of the open loop amplifier having a gain A. These are the output connection here, and this is the input connection here. Now this is voltage, that means output is sampled as a voltage. For sampling of the voltage, what we will do, we will connect the load resistance at the output, this is RL, and take these 2 points. So across this load resistance you will get the output. So here the output is obtained. So here you will get the output V0. Output across this volt, this is also V0. This output is also V0. Same V0 is going here, and I will use the feedback circuit here having a feedback factor beta, and this voltage, output voltage, is applied to the feedback circuit. So this is the voltage sampling. This is called as voltage sampling. Now at the input side, what you will get here, you have to make the series connection. So here I will use the series resistance RES here and voltage source VS here, like this, and with this I can apply like this connection, and here I can apply this feedback voltage, sorry, and here I can use this feedback voltage. This feedback voltage here I can use here like this VF. So this feedback voltage is applied in series with the voltage source. So this is called as series connection. So this connection is the series connection, and this connection is the voltage sampling. Voltage sampling. So this type of topology is called as the voltage series feedback. Dear students, next time we will go through the details of this feedback circuit. What are the effective of the negative feedback, and where these negative feedbacks amplifiers are used, and different types of circuits as an example using each type of topology. So next time we will go to the other topology, some derivations and the relation with the feedback circuits. Thank you very much for listening this video, and I request you go through the details of the feedback amplifier either from my notes or from the standard books. Milliman Halkins is the standard book used. You can go through it, and you refer the university question paper, at least last 5 years questions on the feedback amplifier. Thank you very much. Thank you.